So last class we started talking about properties of exponents, right? And the first thing we did was we did a definition. Given a natural number n, b to the n power equals b times b times b times b n times, right? So we recalled that b cubed, b to the third power, is b times itself 3 times. So b times b times b, right? We did it with numbers. I have 3 to the fourth. That's 3 times itself 4 times, right? It's not 4 times 3. It's 3 times 3 times 3 times 3. 4 times, right? Put it in our calculator. We got 81. Okay? And then we came up with the product rule. And we came up with these rules just from the definition. If you can't remember that when you multiply b to the m times b to the n, that's b to the m plus n, you can write out a little example, right? Don't use 2 and 2 when you're thinking of an example. Use something besides for 2, right? Because if I did 2 and 2, that would be b to the fourth, and I can't tell if I'm adding or multiplying. So don't always do 2 in your example. So b to the third equals b times b times b. B squared equals b times b. And I added those up, and that's b to the fifth. Then we did an example here with a lot more stuff. So let's do another example with more stuff. Number 5. Oops, sorry. Okay. So my first question is, what's my power on y here? 1. If there isn't a number there, it's a 1, right? There's an implied 1. Okay? So now in order to multiply these things, I'm going to multiply numbers times numbers, x times x, y times y, right? I'm multiplying my like terms. So what's 3 times 4 times 2? 24. And then I have x squared.
Oh, wait, can I have a question?
Yes.
Can't you just distribute it to both and then combine them?
Distribute what to both and then combine them?
So
you wouldn't distribute to both because I would just throw it off.
But that's a very common mistake. Your question is, so note.
You would only distribute the 3 to the first.
3 times x times y, right? Okay.
The only reason I thought that's because I know sometimes when you learn the distributive property and you have an equation like that, and there's not really exponents, you would distribute it to both sets of parentheses.
Okay, so let's talk about when that happens, though, right? Okay, so this equals 3xy, right?
Yeah.
Let me throw some parentheses around x and y. Sometimes people's thought is, do I multiply 3 times x and 3 times y, right? Some people say, oh, let me distribute this. 3x, 3y. Okay, that equals 9xy then. What? That's not okay, right? I'm not distributing it twice. But why is that?
It's not really an equation.
Because the 3 is attached to the x, and then it's multiplied by y. That's the way it's written out.
It's because the operation is multiplication, right? You're thinking, what you're thinking is, did I give you your paper back? No. Okay. What you're thinking is 3 times x plus y.
Okay, yeah.
You're thinking the operation of addition here.
Okay, yeah. We're getting that.
No, but this is, a lot of people make this mistake, right? This is 3 times x times y. You're just multiplying 3 to the thing, right? This is 3x plus 3y. These are different.
Okay.
This is very bad. Okay? this is the correct answer. Just because I throw up some parentheses doesn't mean I need to distribute, right? It's a nice way to say I'm multiplying.
So what I would do, like first, like I know what you're doing is like you're doing 3 times x, and then you're kind of combining 2 steps into one, like by going 3, like let's do like 3 times 4 times 2, it's like 24, right? But I would like to take the 3 and distribute it first, and then
I don't want to use the word distribute. Distribute is, remember we talked about the distributive property, and that was in this situation when you have addition between terms. That's when you distribute.
Okay.
This is not distributing. This is simply multiplication. Right? You're distributing if the operation between terms is addition. Here, the operation between terms is multiplication. So we're just multiplying.
Okay.
So first, you want to multiply these 2 numbers? Is that what you're saying?
Yeah, I would just apply the 3 to the first set of parentheses and then go from there. But
Sure, that's fine.
Yeah, you're kind of combining 2 steps into one, essentially.
Okay.
Or you just look at, but you actually view it as just one step.
Yeah.
Yeah.
Because I'm just multiplying some numbers here. So if I want to multiply 2 times 3 and then multiply it by something else, that's fine. If I want to multiply 3 times 4, okay, that's 12 times 2. And if you want to write down 12, then write down 12 times 2, and that's 24. That's fine. Or if you want to multiply all the numbers and get 24, that's fine.
And it's all multiplication. That's why you're able to do it specifically like that.
It's all multiplication. I'm just multiplying.
Okay.
Do you add or multiply the exponents?
So Liv's question is, do we add or multiply the exponents? That is what the question is asking, right? There we go. Right? Okay, so now, I've taken care of all my numbers. Now let's take care of all the x's. Because the operation is multiplication between x squared next to the 4th, I'm going to add the exponents. So I get x to the 6th. And then I'm going to multiply y times y to the 4th. Y to the 5th. Because of that invisible 1 there, right? So again, if you get to a test and you can't remember, am I adding these exponents? Am I multiplying these exponents? Write out a little example. Right? You guys can all do this from the definition. X cubed or b cubed is b times itself 3 times. B times b times b. B squared is b times b. I got b to the 5th from here. I added those exponents. So it's the same thing here when you're multiplying. Okay?
Where I could get confused would be where...
Okay, don't say your confusions out loud, because sometimes people, that's what they remember.
Okay. No, okay. It's like a psychological thing. Okay. So
It is.
All right. So why does the y in the first set not turn into a 3y?
Because of this. That's what you're doing. That's everybody's biggest mistake. If I had 4x squared plus y, something like this, then I would distribute it in. But I have multiplication here, right? All of this is multiplication. Okay, let's do another example. All right, now I'm really messing with you guys. I'm going to make that next bit. So I have 3x times 4yx squared times x plus y. So even when I'm reading it out, I'm saying the operation, right? 3x times 4yx squared times x squared plus y. So if I'm multiplying variables, I'm adding those exponents, right? Okay, so what do you guys want to do first? How about we do multiplication first, right? Okay? So here I'm going to multiply the numbers times the numbers and then the exponents with their like terms. Okay? So let me cover it. 3 times 4 is 12. X times x squared is what? X to the third because I'm adding those exponents. And then I only have y to the first power. And I'm going to copy down what I have. And now I distribute. The operation here is addition, so now I'm going to use the distributive property. So I'm multiplying this whole thing, and I'm distributing it. Okay, so when I do 12x cubed y times x squared, the only thing that's going to change is my power on x, right?
Yeah, x to the fifth.
So I have 12x to the fifth y plus 12x cubed y times y. Y times y is y squared. Good. 12x cubed y squared. And that's my answer.
I got that from, I didn't do the whole, I mean, I guess I did do the whole distributing in my head, but then I just, like, I went from step 1 to just 12x 5 y squared, the answer.
Okay. If I were doing this, I would write this middle stuff just to stay organized. Okay, how do you guys feel about this? Another example? With the addition?
Yeah.
Like this? You like that? Okay. 4ab plus 2ax times 8x squared a times 2x. Okay. What do we do?
The 8, like the last part, what was the
Sure. I could change the order of this because x times y is y times x. That means it's commutative. Order doesn't matter when I'm multiplying. 2 times 3 equals 3 times 2. Bless you. Right? I can change the order. That doesn't matter. If that helps you see it, that's fine. Let's clean this up a little bit over here to the right. So 4ab plus 2ax. So now I'm going to clean this up. So what is 8 times 2? 16. X squared times x. X cubed. I'm adding those exponents, right? Here there's a little invisible 1. 2 plus 1 is 3. And that's because x squared is x times x, which ends up being x cubed. And then a is just a to the first, right? Okay, now I'm going to distribute. I'm going to distribute this whole thing to each term of where I'm adding. Okay, so I have 16x cubed a times 4ab.
64x cubed a squared b.
One more time, Blair.
64x cubed a squared and b.
Okay, who agrees? One person saying yes. Who says no? I feel like this half, I got one thumbs up from this half.
Wouldn't it be x to the 4?
So I'm multiplying this times this.
Oh.
So we did the number, x, there's no other x here, so I'm just copying x down. Here I got a to the first times a to the first. That's a times a, which is a squared. And then I just have the b, right? So now I'm going to move to the next term. This times this.
32x to the 4th a squared.
32x to the 4th a squared. What do you guys think? Yes, I agree. So here I'm using really low numbers because if we wanted to write out the definition, we could, right? If I wanted to write this is 16 times 4 times x cubed times a times b, and then you get a squared from that, that's fine. Does all this make sense?
And that's your answer?
Yeah. Okay? So let's do the next rule. I'm going to do the quotient rule. Quotient means division, right? So when I'm looking at the quotient rule, I'm thinking, okay, what am I dividing? B to the m over b to the n equals, oh my goodness, I'm at the test and I can't remember. Let me write down an example. B cubed over b, let's do b to the 5th over b squared. Oh my gosh, I can't remember. What is the rule? I'm on a test. Okay, what is b to the 5th? B times itself 5 times, right? B times b times b times b times b. Okay? What is b squared? B times itself twice, right? B times b. Okay, now I'm going to cancel my common terms. B over b equals 1, b over b equals 1. I'm left with b times b times b, which equals b to the 3rd. Okay, so from this example, b to the 5th over b to the 2nd, I get b to the 3rd. What did I do with those exponents? Subtracted them. I said the exponent on the numerator minus the exponent in the denominator. So you don't have to memorize these rules, right? It doesn't hurt. But as long as you understand the definition of something to a power, you understand the definition of exponent, you can come up with those rules on a test, on a homework, wherever, just like we just did right now, right? Okay. So that was example number 8. Let's do another example, number 9. All right, I'm going to try to trick you guys. Get ready for it. So I have negative 2 to the 7th over negative 2 to the 5th. Okay, what do I do with my rules of exponents?
If it's a negative times a negative, it's always a positive.
What do I do with my rules of exponents first?
To the
I'm just,
negative 2 to
I have the same base, right? And I'm subtracting the exponents, right? So I get negative 2 to the 7 minus 5, right? Power on the numerator minus power on the denominator, 7 minus 5. And I get negative 2 to the 2nd. We talked about my exponent is only applied to what it's touching, right? My exponent is touching the parentheses. So it's applied to everything inside of the parentheses. So this is negative 2 times negative 2, which Blair said is positive, right? Negative times negative is positive. So this is positive 4. Good? Let me do another one. Number 9 and number 10 are very different, right?
Yes.
Do you see that? This one Number 9, the exponent is touching all of negative 2, right? Number 10, the exponent is only touching the 2. It's not touching the negative. Right? So the power only applies, let me write a little note over here to the side. So negative 2 squared is negative 2 times negative 2, which is 4. Negative 2 squared is negative, but the power is only touching the 2. So I have some negative out in front, and then it's 2 times 2. So this equals negative 4. Right? Super different. Okay? So if you wanted to write this one out, you could. You could write negative 2 times 2 times 7 times, right? Over negative 2 times 2 times 2 times 5 times, right? What did you guys get for your answer? It's 4, it's negative 4. I have a negative number divided by a negative number, right? Negative divided by negative should be positive. Right? That sign doesn't have anything to do with the power. That sign doesn't have anything to do with the exponent there.
So you're just taking away the 5 from the 7.
Yes. So here I'm thinking negative divided by negative is positive, right? And now I'm looking at the 2 to some power, right? So this is 2 squared, which is 4. Those negatives don't relate to the exponent. Okay? All right, so there is the homework due tonight.